All right, 4-1 and 4-2 review. We're going to have a quiz tomorrow, so review today. Special right triangles, let's start with that. With the 45, 45, 90, we really start with a square. And so that would be side, side. By doing some Pythagorean theorem, we have side times the square root of 2. That would be the hypotenuse. Now you should be able to answer any question about a 45-degree angle. In other words, if you wanted the tangent of 45 degrees, that's equal to 1. Side divided by side is 1, or 1 divided by 1. Matter of fact, if you want to divide all the sides by side, that would be 1, that would be 1, and that would just be the square root of 2. If you wanted sine of 45 degrees, that would be opposite 1 over hypotenuse. That'd be the square root of 2, so square root of 2 over 2. So the first part of your quiz tomorrow, you will not be able to use your calculator, and you have to answer some questions like, what is the exact value of the sine of 60 degrees? Well, with 60 degrees, you start with an equilateral triangle. That makes this side, that makes this 1/2 s, and then this is the square root of 3 over 2s by doing Pythagorean theorem again. Because we're cutting that 60, 60, 60 in half to get that 30 up there. So now the sine of 60 degrees is opposite over hypotenuse, square root of 3 over 2s over s, but really just square root of 3 over 2 because the sides will cancel each other out. Now we could get the decimal value of that, but the instructions will say give me the exact, and you won't be able to use your calculator. So you have to know square root of 3 over 2. Any questions on that? You have to be able to duplicate this for tomorrow. Find the 5 other trig function values if cosine of theta is 3/4. All right, so we can draw a triangle. We can put the angle either here or up above. Let's put it there. Here's theta. Cosine is adjacent over hypotenuse, so we have 3 and the 4. And we have sine of theta, cosine of theta, tangent of theta. I usually just write all 6 of them. I know one is given. Then we have cosecant of theta, secant of theta, and cotangent of theta. Sine and cosecant, again, they go together. You would think it would be cosine and cosecant. That would make sense to me, but you got to remember that it's backwards, in my opinion. So sine and cosecant are reciprocals. We've been given cosine, that's 3/4. Secant is 4/3. That one's the easy one. But what about this third side over here? What if we called that b? We'd have 9 plus b squared equals 16. B squared equals 7. B equals the square root of 7. Well, now we can get all the others. Sine is opposite over hypotenuse. That's square root of 7 over 4. Tangent's opposite over adjacent. That's square root of 7 over 3. Now we have to do reciprocal. 4 over square root of 7, which is 4 square root of 7 over 7. And then we have 3 over square root of 7, which is 3 square root of 7 over 7. And I noticed on the quiz we have reduce and rationalize everything. So you will have to rationalize your fractions for the quiz tomorrow. Convert to radians or degrees. We have 5 pi over 12 over degrees is equal to pi over 180. We can cross multiply. We have pi d equals 180 times 5 times pi over 12. Well, on this one, we can divide both sides by pi. Those are gone. So we really have to worry about 180 degrees divided by times 5, and then we can divide by 12. So that's 75 degrees. Now let's put a little bit of meaning behind it. I promise you, if you understand it, if you understand the meaning just a little bit, it's going to make sense, and it's going to stick a little bit better. Now why? Let's find out why 5 pi over 12, why is it 75 degrees? Well, if you take pi and you cut it into 12 pieces, and I'm not going to do that, but I will say that really instead of pi, we're really taking 180 and we're cutting it into 12 pieces. Now, I know we've already done the problem, but hopefully this makes sense to you. We've divided it into 12 pieces. Now, each of those pieces is worth 15 degrees. So each of those pieces is worth 15 degrees, and we need 1, 2, 3, 4, 5 of those. We need 5 of those 15 degrees. Well, if you take that times 5, you get 75 degrees. So what you can get out of that is pi over 12 is the same as 15 degrees. Because if you take 180, divide it by 12, you get 15. Now, if I don't know if that made that more clear or less clear. But if you didn't understand what I just talked about, just make sure you do that, and you'll get the degree measurement. 225. That's a degree over radians is equal to degrees. We're using 180 over pi. But I actually recognize 225 degrees. 225 is 45 degrees past 180. There's your 225. Well, 45 degrees past 180, that's a pi over 4. 1/4, 2/4, 3/4, 4/4, 5/4. I'll bet when I get done with this, I get 5 pi over 4. Let's find out if that happens. 180r equals 225 pi. R equals 225 pi over 180. 225 divided by 180, enter. I don't really want the decimal. We go math, fraction, change to a fraction, and there's your 5 pi over 4. Once you use these degrees enough, you'll recognize 60 degrees as pi over 3. You'll recognize 135 degrees as 3 pi over 4. You'll start recognizing these numbers. But when in doubt, just use the conversion. Evaluate sine of 34. This is just to make sure you put your calculator in degrees, because now I'm going to hit one of these 3 buttons, sine, cosine, or tangent. I'm going to hit the sine. Sine of 34, the value is 0.559. So can you use your calculator? Now, we don't have a secant, cosecant, or cotangent button, but we don't need one. Secant's the reciprocal of cosine. So we have 1 divided by cosine of 28. So 1.133. 1 divided by cosine of 28. That's what you need to do for that one. Solve the triangle. Angle A, angle B, angle C. Side A, side B, side C. We'll do a lot of this in Chapter 5, solving triangles. Lots of different cases. But for right now, we have 35 degrees for A. C in this case is 90. Chapter 5, we get away from right triangles and we do all kinds of triangles. We don't know B, however, A and B have to be complementary. So this has to be 55 degrees. We know side A is 24, and we need side B and side C. We can get side C by doing what? Opposite, adjacent. We can do sine of 35 is equal to 24 over C. So we can use sine to find that hypotenuse. 24 divided by sine of 35. 41.843. 40, what is that? C. 41.843. I can do this. I could probably use cosine also, but I could just square this answer. Square. And then what? Add a, oh, no, let's just use cosine. I was going to use Pythagorean theorem. How about cosine of 35 equals B over the 41.843? We could do that. So I need to multiply. Clear that. I have the answer right here in my calculator, all of it, times cosine of 35. And that should be a pretty accurate answer. 34.276. That's called solving the triangle, where you find all the sides, all the angles. Oh, wait, I had something down there. A straight row at the top of the hill is 2,500 feet. All right, so this is the 2,500. and makes an angle of 12 degrees with the horizontal. So there's 12 degrees. Find the height of the hill. So we're finding height right here. That is sine of 12 equals h over 2,500. So we need to multiply. 2,500 times the sine of 12. And I know my calculator's in degrees. So h is equal to 519.779, and that's going to be feet. Write each decimal degree measure in degrees minute second form, and each degree minute second measure in decimal degree form to the nearest thousandth. On this one, we certainly have 38 degrees. We have those whole degrees. Then that's about a half a degree. So I'm guessing roughly about 30 minutes. 0.498 times 60. 60 minutes in a degree. So there it is, roughly 30. But we'll say 29 minutes. And then we're going to minus that 29 off. Take the whole part off again. And then we'll take 0.88 times 60 again, which is 60 seconds. So you keep just taking that decimal part and keep going with it. And then we have 52.8 seconds. When we go the other way with it, we will have 115 plus the 24 over 60, and then plus 44 over 3,600. We're trying to get everybody to degrees. Well, there's 60 minutes in a degree, and there's 3,600 seconds in a degree. Just like there's 3,600 seconds in an hour. Hour, is that right? Yeah, an hour. 15 plus 24 divided by 60. And then this last part doesn't add a whole lot, but it adds a little. 3,600. So 115 degrees, 115.412 degrees. You have one positive and one negative angle that is coterminal with a given angle. We just need 88 plus 360. That's 448. And 88 minus 360, that's negative something. Negative 272. 272. And then with 7 pi over 4, we add 2 pi. That's all the way around the circle in radians. We need common denominator. That's going to be 8 pi over 4. So 15 pi over 4 is coterminal. It's at the exact same place. We could find that out. Let's see, there's 4, 5, 6, 7. Right there. There's 7 pi over 4. But if we go 4, 8, 12, right? 12 and 1, 2, 3 more, we get to the exact same place. You just have to go all the way around the circle again. Then we have 7 pi over 4 minus 2 pi. That's equal to 7 pi over 4 minus 8 pi over 4, which is just negative pi over 4. So if you want to get to this spot right here, all you got to do is just go the other direction, 1 pi over 4, just 1 pi over 4, and you're there. That's what that answer is telling you. You're at the exact same place. Find the length of the intercepted arc. If the radius is 15 centimeters, the angle is 38 degrees. Length of the intercepted arc. Okay, so arc length is equal to r theta, just like 2 pi r for all the way around the circle. That's circumference. So the arc length is the radius times 38 pi over 180. You can't have the radius times the degrees. That doesn't make any sense. Radius times how many radians do you have? How many of those radii do you want? All right, so 15 times 38 pi divided by 180. 9.948, what did I give? Yeah, centimeters. Find the arc length if the angle is 110 degrees and the radius is 33 feet. I don't know why I needed another one, but apparently we did. 33 times 110 pi over 180. and this one is 63. So 63.355, and this is feet. Find the angle in degrees if the area of the sector is 56 feet per second. All right, so we have area, 1/2 r squared theta. You'll have to know that for tomorrow. Make sure you have it memorized. There's only a couple little formulas you need to know. The area is 56. The radius is 12 times theta. So we have to take half of 144. 144 divided by 2, 12 squared. And then take 56 divided by 72. That's 0.7 repeating. So we get theta is 0.7777, keep on going. But that's in radians, so it's not quite 1 radian. But they asked for it in degrees. So I imagine if it's not quite 1 radian, it's not quite 57 degrees either. It's going to be less than that. But we need the 0.777 repeating over degrees equals pi over 180. I need to take this answer in the calculator times 180 and then divide by pi. So there it is, not quite 57 degrees because it's not quite 1 radian. So it ends up being the degrees is 44.563 degrees. And I believe this is our last problem. Then we have a little review worksheet for you. A farmer spots a raccoon in a tree at an angle of 13 degrees. So I think this is the lower one. Right there. Another raccoon is spotted by the farmer at 20 degrees. Up there. If the farmer is standing 100 feet from the tree, how far apart are the 2 raccoons? This is the 100 feet right here from the tree. This one was 13 degrees. And this bigger angle to the bottom still, that's the 20 degrees. The distance they want is between the 2 raccoons. Maybe we'll call that x. We'll call this other distance y. So the whole, from the bottom to the top raccoon is x plus y. We have tangent of 13 equals y over 100. And we have tangent of 20 is equal to x plus y over 100. Well, we can get what y is. Y is equal to 100 tangent of 13, and we can get that value. And then on the other equation, I can multiply by 100 equals x plus 100 tangent of 13, because that's what y equals, and we can do a little substitution. So to get the final answer on this one, we can take 100 tangent of 20 minus 100 tangent of 13. Press enter, and there we have the distance. So the x is equal to 13.310 feet.